Okay, so I'm on page 253 of the Student Journal, section 8.2, looking at numbers 5, 6, 7, and 8. So the zeros of the function are basically the values of x when f of x equals 0. You could also think of it as y equals 0. So basically what they are is they are x-intercepts. That's what they are. So for each of these problems, what you're going to do is you're going to plug in y, 0 for y, because at an x-intercept, it's always x comma 0, where the y value is 0. So if I let y be 0, I can then use factoring to solve this. And then, so I take out a -1. I'm left with, I'll use this space here, I'm left with a difference of 2 squares. And then to find the values of x, I just use what we know of as the zero product property. So I'd have x plus 1 equals 0, x minus 1 equals 0, and I would get x equals -1 and x equals 1. Remember, you can also write that as plus or minus 1. So these problems are basically things we've done before. It's just the notation is a little bit different. So for the problem 7 and 8, where you see this n of x or this p of x, you're going to let that be 0 and do the same process as up above. In the word problem, I'm just going to go over part A. That's mostly what I'm concerned with, not so much part B, so I'm going to cross that out. They give you a quadratic function. This is technically in the form of y equals ax squared plus c. They say that the height is in feet. So let's take this as height. And then you have a falling object. Oh, it's a tennis ball. So we have a tennis ball right up here, right? And it's being dropped from this building. So maybe imagine someone's throwing it down to the ground. Here's my ground down here, acting sort of like the x-axis. They don't have an x though, they're using t. The reason they're using t is because they're dealing with time in seconds, right? And then they say that it's after it's dropped from initial height s sub 0. So this is my initial height. Right here is the initial height. The initial height is where it starts. This is also going to represent my y-intercept. Okay, so your y-intercept, which remember we know that c represents our y-intercept. Remember it's 0 comma c. It says my initial height is 400 feet. So this is 400. So my y-intercept of this graph is 0, 400. What we are going to find is where it hits the ground, which to us would be an x-intercept. An x-intercept has ordered pairs like x comma 0. In this case, it's a t. So basically, the way you're going to do this problem is you're going to consider the function f of t equals -16 t squared. And instead of s sub 0, I'm going to put that initial height in there, which happens to be 400. And where the ball is hitting the ground, that is your x-intercepts, or your zeros of the function. So you're going to let f of t be 0, and then you can factor from there to solve. So I'm going to go ahead and I'm going to take out that -1. Probably could have taken out a bigger number from there, but that's okay. Oh, is it a... Oh, this becomes minus. I messed up. That's a minus. And then I just keep solving from there. This is a difference of 2 squares, so 4t plus 20, 4t minus 20, and then zero product property to solve. So when I solve each of these, I'm going to get 2 different answers. And what you're going to notice is one of them is not going to work. because t represents time. Time can't be negative unless you're in Back to the Future. So my answer is not going to be this one, but it's going to be this one. So the answer to this is that it will hit the ground after 5 seconds. So for part B, this part B is different than the one in your homework. For part B in your homework, I would go to page 428 of your textbook and look at part B of that example, because it's more like the one in your homework than this one is, so that's why I'm not going to go over that one. So if you have questions on this, let me know. We can go over it at the beginning of class. So I hope this helps.